It literally takes fire and brimstone to transport gold to Earth's surface. The processes that haul gold up to the surface from deep within Earth's mantle rely on the sulfur that bubbles beneath active volcanoes. Two new papers have agreed that some forms of sulfur from molecular bonds with gold that would otherwise remain sequestered in the mantle, allowing the precious element to rise. And what they don't quite agree on is which form of sulfur is most important. According to the numerical modeling and experiments conducted by a team of geologists led by Deng Yang He of the China University of Geosciences, trisulfur is the key. But according to experiments conducted by Stefan Farsang and Zoltan Zajac of the University of Geneva, bisulfide is a crucial player. Both sets of results are interesting and worth following up because understanding how gold deposits form can help us make the most of this beautiful, valuable, and resourceful resource. Gold deposits are often associated with volcanic activity at places where tectonic plates meet, and there the edge of one tectonic plate can slip beneath the adjacent plate, creating what's known as a subduction zone. Interactions between the two plates create a region riddled with earthquakes and volcanoes, such as the long volcano chain known as the Pacific Ring of Fire. The gold in these deposits originates deep below Earth's surface in the mantle. Left to its own devices, there the dense metal would stay, but it gets incorporated into the magmas that rise up via volcanic activity to the surface, where it is deposited. Scientists believe the key is to its transport is sulfur. Sulfur bonds strongly with heavy metals, including gold. But what form that sulfur takes to transport gold through Earth's subduction zones is a topic of debate among Earth scientists. Deng Yang He and his colleagues experimented with different pressures and temperatures to develop a thermodynamic model that could predict the real-world conditions that result in gold transport. They found that at a set of very specific temperatures and pressures, where water is heated and oxidized as Earth's crust sinks, gold and trisulfide bond to form a soluble complex with the formula AuHsS3. This complex, their calculations showed, can transport gold concentrations of several grams per cubic meter of fluid, more than 3 orders of magnitude higher than the average abundance of gold in Earth's mantle. It's an extremely efficient means of slurping the gold out of the mantle and dumping it into the crust. This thermodynamic model that we've now published is the first to reveal the presence of the gold trisulfur complex that we previously did not know existed at these conditions, says geologist Adam Simon of the University of Michigan. This offers the most plausible explanation of the very high concentrations of gold in some mineral systems in subduction zone environments. But it may not be the only means of transportation. In their experiment conducted at the University of Geneva, Farsang and Zajac found a way to tweak the oxidation state of the sulfur in their experiment, adding it to pressure conditions and temperatures of 875 degrees Celsius, which is a whopping 1,607 degrees Fahrenheit, consistent with the temperatures of natural magmas. Previous experiments, including a heavy-sided 2011 paper, had shown that trisulfur was responsible for the transport. The new results showed that bisulfide, hydrogen sulfide, and sulfur dioxide were all strongly present at magmatic temperatures. This is interesting because bisulfide plays a role in metal transport in hydrothermal fluids, which are lower in temperature. It was thought that bisulfide could not exist at magmatic temperatures, but the work of Farsang and Zajac found that it can. By carefully choosing our laser wavelengths, Farsang says, we also showed that in previous studies the amount of sulfur radicals in geologic fluids was severely overestimated, and that the results of the 2011 study were in fact based on a measurement artifact, putting an end to this debate. Them's fighting words. Your move, trisulfur. And this is from Proceedings of National Academy of Science and Natural Geoscience, respectively, from Michelle Starr on Science Alert. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.